If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 106 to up to question number 110. Okay, then let's try to solve these 5 questions. The single phase 50 Hz iron core transformers in a circuit has the both vertical arms of the cross sectional 20, vertical arms of 20 and horizontal arms are of 10. So this is more thicker, then this is thin. These two are thin, this is more thicker. If the two windings shown are wound instead on opposite horizontal arms, then the mutual inductance. So what is the mutual inductance? Is the flux that is linkage between these two due to this. So the flux linkage was this one, phi. Now if you change this is to this type of winding, because this is thinner and this is thicker. Now if you want on this, now the mutual flux linking to this will pass through this. Now phi is always equal to A into B. B is the flux density that depends on H, strength, that is Ni. So N and I is fixed, so this is fixed. So depending on area, phi will change. So if you are giving the mutual flux that is flowing between these two is giving more area, so more flux will flow. So more mutual flux in reactance, inductance will come. So that means it will be doubled, because area you have doubled, so phi will be doubled. So L will get mutual L, that is M will also get doubled. So that's why it is option A. Because if you connect this one, you see the mutual flux flowing between these two getting more areas. So that's why it will get double. Here it was flux was flowing through this, so this area is more than that. So that's why it is double. So its answer is also double. Now if you come to question number 107 and 108, the star delta transformer shown here is excited on the start side with a balanced 4-wire 3-phase sinusoidal voltage supply, rated magnitude. The transformer is under no load. With S1 open, S2 open, the flux wave will be. With S2 closed and S1 open, the current waveform in the delta winding. Now this transformer, when you have seen any transformer, if you see it is delta star to delta, delta to star. If you see the equivalent drawing, equivalent circuit, so there is a core branch and there is this one and this is the load current. So whatever in primary current, this is actually two branch. One is that load current which is getting reflected from secondary to primary, plus this magnetization current. So that is this current you get. Now this current, that means there is a current IM which is beyond this current. Now where to show this IM, where this IM is going? This IM is magnetization current or magnetization inrush current, which is very rich in third harmonic. So we generally say it is third harmonic current. So where is this current going? In the circuit it is okay, but in the figure you see, if I say start to delta, then this is actually the load currents. So where is this current IM? What is the path of flowing IM? So it is generally done if it is a start to ground connected, then this third harmonic current will flow through this ground. And if it is a delta, suppose it any side, it is okay. If it is a star, it is not required that both sides there should be path. If you give path in only one side, then in that side only that will flow. So you can think it that way. If my star side is star ground connected, so the third harmonic current will flow through this ground. So it will not go to the load side. That is okay. If it is delta, then you can see there is a closed path between these three windings. So that third harmonic current will circulate here in between these two. So the load current plus this will come this side. Here also the load current plus this magnetization current which is coming to ground, then plus this. So actually this is the summation of these two currents. So you have to see that is the load current plus this magnetization inrush current. That's why you have seen when there is a saturation that I was not sinusoidal, it was PQ. We have explained on this one. Now what happened if you open this S1 and S2 both? S1 opening, that means you have no ground. You are opening S2, that means it is open delta. So this connection is also not there. The circulating path is not possible. So that means you cannot have third harmonic component here. So third harmonic component is not possible because that will not, that there is no circulating path. So you can say because it is not possible, so your current will be properly, what is your I1, that I1 will be a sinusoidal. Now if you see your BH curve, what is your BH curve? This is your BH curve. This was actually I, this is phi. So if your I is a sinusoidal, if your I is changing with sinusoidal, this is actually I, you are increasing with time and then gradually decreasing, whatever. Now you see your phi, what will be the graph of the phi? Here suppose I am doing. So if you see, because your I is properly sinusoidal, here I is sinusoidal. Why I is sinusoidal? Because no third harmonic. So your I is increasing, okay, your phi is getting increased after some time, okay, here it is going here. So after that the variation of phi is very small. There will be no such variations because I is again coming back to returning here. So this phi variation will be very small. It will go somewhere, and so this portion phi, you can see it is flat. It will go somewhere. It will start after some time. You I increase, then it will increase, then it will be flat. If you you say your phi is here to here, this variations is very small. So phi will be somewhere flat, and from here again when it comes to 0, it will reach again. It will maintain that value, somewhere come to 0. If you go beyond that one, then it will come to 0. So this phi will be not doing instantaneously, as it will wait for some time, because this depending on that hysteresis loop. So it will be something, your phi will be something of flat topped, you can see. So this phi will be a flat topped with third harmonic. The core flux, not the current. Current will be here sinusoidal because no third harmonic, but it will be, because this one is flat, it head will be topped flat, because your I is sinusoidal, no third, because of this third harmonic actually it gets sinusoidal. So it will be flat topped with third harmonics. That means your option B. Now if you come to 108 with S2 closed, now S1 is open, okay. Now because you have closed now S2, there is a path for flowing this third harmonic current. Then the current waveform in the delta, what will be the current in the delta? Because it is no load, so no other load current will be there, only third harmonic current will flow here. So it is the only third harmonic, that's why it is option C, because now you have a path. Now if you come to question number 109 and 110, the circuit diagram shown two winding lossless transformer with no leakage flux excited from a current source IT, whose waveform is shown this one. The transformer has a magnetizing inductance this one. The peak voltage across AB with S is open. When S is open, it is no R is there, so it is simple LDIDT, or that is transformer inductance whatever MDIDT, because if you see this one equivalent circuit 109, so this portion is only there, that magnetism. So this is highly inductive, we only take about L. So what is this voltage? LDIDT. So what is L? L is 400 by 5 into 10 to the power minus 3. And what is DI? Change in current is 10 ampere, and what is change in time is 5 millisecond. So that is DIDT. So if you do this one, it will get 254.64, that is, which is equal to your option D, that is 800 by pi. 10 to the power 10, you can see it is 800 by pi. So that is your option D. Now if you come to 110, the waveform of the IT changed to this. The peak voltage will be with S is closed. Now once you close this one S, now you have two paths. One path is this one, that magnetization branch, and one is this load. So this I will have two current branches. So this I has actually divided into two branches. This is 40 by pi, okay, L, and this R is 30. So what is Z? Z is equal to 30 plus, this is 30, okay, and this one X is equal to, so X is equal to omega into, X is equal to omega into L. So what is omega? Omega is equal to 100 pi they have given. So if you do this one, and 10 to the power minus 3 is also there. So pi get cancelled, and it will be 40J. So current will be divided into this branch. So whatever current is coming here, that, because you are asking this voltage, either you take this or this, whichever, both will be same. So let me take this voltage. So what will be this voltage? This resistance into whatever current. So current will be divided into two parts. They are asking peak voltage, so I will take peak current, I peak, into then divide it into this parallel combination. So current division, this current you want to find, so you multiply by this one divided by this plus this. So if you do this one, finally you will get your answer as 240 volt at an angle of 36.86. So this is my answer, 240 volt, option B. If you like the video, then press the like button and please give your valuable comments in the comment section.